Hey guys! In this video, I'm taking a look at the new Raspberry Pad 5 from BIGTREETECH. My main goal in this video is just to briefly show you how things work so you can make an informed decision on whether it does what you need it to do. I'm breaking this up into 4 sections. In the first section, I'm going to briefly describe what this is. Then I'm going to do a little bit of reverse engineering and figure out how everything works. Then I'm going to go over the documentation that was posted by BIGTREETECH. And then finally, I'm going to give my thoughts on it. So this is an interface board for the newest Raspberry Pi compute module. It's similar to the CM4 I/O board that Raspberry Pi Foundation makes, but this has an LCD and a touchscreen built onto it and a couple other things. BIGTREETECH gives a bunch of possible uses on their website, and the most prominent one they show is a 3D printer interface board. That's not my goal in this video though, so let's move on to my main focus, how this thing works. And let's start by looking at the display. It has a fairly standard 800 by 480 resolution screen, and it uses an interface called DPI. It runs in 24-bit RGB mode and uses 8 pins for each of the colors red, green, and blue. I use the same interface on some of my Raspberry Pi boards, and it lets me use all the GPIO pins to directly drive an LCD. BIGTREETECH went a slightly different direction on this one, and they're using DPI, but they're adapting it from the DSI port. They're using a chip called the ICN6211, and they're adapting the display serial interface coming from the Raspberry Pi to the display parallel interface for the LCD. The benefit to what they did here is that all the GPIO pins are still usable for other things and are available on this 40-pin header with the same pinout as the normal Raspberry Pi boards. It also appears this method is a little more power efficient and maybe a little cheaper than the HDMI to DPI chips out there, but it basically accomplishes the same thing. Overall, it might be better for a battery-powered project than the HDMI chips. This also appears to be the same method used in the official Raspberry Pi displays to interface the DSI port with their LCD panel, and it appears many of the displays even use this exact same IC. The display also relies on an STM32 microcontroller, and I believe it's initializing the ICN6211 at power-up. It also controls the backlight brightness, which you can adjust with these buttons. The 2 on the outside increase and decrease the brightness, and the one in the middle rotates the display 180 degrees. All the touch detection also appears to be happening within this same STM32, and it's then read by the Pi using I2C. I'm not too familiar with how the official Raspberry Pi display handles touch, but this one appears to either implement it in the exact same way, or it at least emulates it so the official Raspberry Pi drivers can talk to it. Alright, now on to USB. This board has 4 USB connectors on it. One of them is USB-C, and the other 3 are standard USB-A connectors. So I made this layout here just to kind of show how everything's connected, so you can get a visual as I'm describing it. So the compute module has a single USB 2.0 built in, and this board has to do some extra things to make all 4 of its ports function, and to let you flash an operating system to the built-in storage on the Raspberry Pi. So starting on the left side, it has this USB switching chip. This chip connects the Raspberry Pi's single USB to 2 devices, a USB port and a USB hub, and it switches between them. It only connects to one of those devices at a time. The chip is controlled by this physical switch labeled USB on the go, and when it's in the on position, it connects the Raspberry Pi's USB directly to the USB-C connector. This is done when you're flashing an operating system. When it's in the off position, it connects the Pi's USB to this USB hub, which splits the single USB into 3 USB 2.0 Type A ports, which can all be used at the same time. There's also a second switch on the USB-C port, and I'll cover that in a sec. I'm just showing it now because it has to be in this position if you want to flash an operating system. Only the USB-C port can supply power to the board. The other 3 are on a power distribution chip, which prevents power from feeding back to the board when it's powered off. So now back to the switch on the USB-C port. This one's just a physical switch and it doesn't control any chips. It just switches the USB port between USB and CAN bus. Like I said before, when the switch is in this position, it functions as USB. But when the switch is in the other position, the USB data pins get connected to these chips, the MCP2515 and the VD230. And these chips create a CAN bus interface using the SPI pins on the Raspberry Pi. And finally, a few other miscellaneous features. It has a real-time clock, the PCF 8563, that works over I2C. It lets you add a battery to keep the date and time when the board is powered off. The board also has an Ethernet port, a single HDMI port, and a CSI connector for adding a camera. And it also has a micro SD port, so you can use the Compute Module Lite, which doesn't have built-in storage. Alright, now I'll take a quick look at the documentation from their GitHub page. They did a pretty good job with the setup guide, and there's enough information there to get up and running. They've revised the PDF a few times since I got the board, adding more details each time. They explain how to get every feature working, including the display, real-time clock, and the CAN bus interface. And they show which switches have to be in which position to flash an operating system. Overall, it's perfectly adequate. And they even included a 3D model for the case, which I printed, and I think it does the job pretty well. And finally, on to my thoughts. The first is on quality. So they use decent components, and the overall quality is good except for two small areas. First, mine had some debris between the LCD and the touch panel. It's a minor annoyance, and it's really only visible when the LCD is off, but it's a small thing that they should pay more attention to when they're building these things. Other than that, the LCD looks great, and my camera really doesn't do it justice. The other gripe is that the USB power distribution IC doesn't appear to be soldered very well. It connects and works just fine, but the placement was a little off, and the connection is a little weak for something that passes a few amps of current. I think for a $100 item, they could do a little more work on the quality control. Most of the components they used are very common, which is a big positive for me because it means I can probably find code examples on GitHub. The DSI to DPI converter chip has me intrigued, and I'm curious whether something similar could be cobbled together for my own projects, since it only has to output a fixed video format. If anyone has any thoughts on this, let me know and I'll gladly prototype it. I would prefer it if when the board was put into USB boot mode, it disabled things like the backlight, LCD chips, and anything else that isn't needed during flashing. I say this because when you flash the board, you're probably powering this using a low amperage USB port on your computer, and that can cause problems with data. I had this happen a couple times when I was flashing a compute module, and it failed to boot because of data corruption. I ended up reducing the brightness until the backlight turned off, and flashing worked fine after that. In fact, I did some tests just to show how much power is being used, and it takes about half an amp of power just at idle, even when flashing isn't taking place when the backlight is fully on. And it drops down to about a quarter amp when the backlight is off. Just something to keep in mind when you're flashing this, and it's probably something they should mention in their manual. I understand there might be other reasons you wouldn't want the USB boot mode to disable the LCD, maybe when booting from a USB device, and this is just a personal preference of mine. I'm not sure whether the CAN bus chips add much value for me personally, but it might be useful if you're using some of BIGTREETECH's other boards. I think it complicates things a little bit, and it can cause some confusion when flashing an operating system. In the end, it probably doesn't add too much cost to the board, so maybe it makes sense for them to add it. All the other features like the DSI chip and the real-time clock make perfect sense to add. As far as I can tell, BIGTREETECH hasn't released any open source firmware for the STM32 and hasn't released any schematics for the board. I think both of these would be really helpful for people wanting to make their own things with this board and tinker with it, and I hope they consider releasing them. Overall, I like the board, and if they can improve the quality control on the LCD and soldering work, I think this is pretty good for the cost and for what it can do. And that about covers it. Thanks to BIGTREETECH for sending me this to test. Thanks to everyone for watching, and a special thanks to everyone supporting on Patreon, Locals, and PayPal. Have a good one, guys.